welcome to the talk. It's not the workshop. So a little bit about me. I live here in Grand Rapids. I don't know. I'm an old guy. As you can tell, I've pulled all my hair out. So that probably tells you that I was around before Google and AI and stuff like that when we would bang our heads against the wall. So, but yeah, I'm around here. So if anyone wants to get a coffee or hang out, Victor and I get a coffee every Friday morning, or try to, depending on my schedule. So, but yeah, and then you can go out to my personal site, which is woodruff.dev. I blog out there a lot. So the agenda, tonight's agenda will be just a basic overview of lots of different things about Terraform. So we're going to talk about what it is, how to set it up, what HCL is. That's the language that Terraform uses for configuration. We're going to talk about state, provisioning, variables and outputs, and then we're going to end up with modules and reusability. So hopefully we can get through everything. If you guys do have questions, please break in, ask me. So this first part, I just want to go over basically the basics of Terraform. So what we're going to do is what Terraform is. So Terraform is infrastructure as code. There's lots of different products. Anyone use anything other than Terraform? Some people use the Azure management. Yep. Oh, Bicep is another one. Yeah. So there's lots of them out there. They all have strengths and weaknesses. So yeah. The great thing about Terraform is you can use it for everything. You can use it for pretty much all the three major cloud carriers or cloud platforms. And what I like about it is it's not just it just isn't there to set up. It's there to keep track of what you're doing. So one of the areas that we will look at is state. So we'll keep state. So yeah, so we can look at like Azure Resource Manager. We can look at AWS Cloud Formation, Ansible, or kind of the Bicep is another one. But I kind of like it just because it, as a coder, as a developer, it allows me to kind of write out what I need to, and then it will tell me if I'm doing it right or wrong. It will also tell me if I'm changing stuff or adding new things. So it's pretty good. So, and it integrates within DevOps pipelines. So you can integrate it into your CI/CD. So how is this different? So I kind of take a look at different stuff. I'll quickly go through this. Terraform versus Azure Resource Manager. Azure Resource Manager is Azure only. So it uses JSON templates, which are a little more verbose and complex, and it only integrate and the only thing it will integrate is with Azure tools and resources. So it is good for that. Okay, so next we're going to look at AWS. Again, AWS is only for AWS. It uses YAML, JSON, so it can be a little verbose, and it really integrates with AWS. So Ansible is the other one that I took a look at and I've used in the past. Ansible is good. The problem with Ansible, it doesn't keep state. So when you build stuff out, it's good for building out the initial, but after that, you're kind of stuck with, like, if you want to make changes, then you have to build a whole nother set of Ansible scripts. and almost tear down what you had and rebuild it. So it also has it's more procedural, and it does use YAML. So I've used it in the past a little bit. I just don't like it because it doesn't allow me to save my state and then change things as I go along in the lifetime of my infrastructure and solutions. So the key difference is that Terraform will they have a lot of good tools. It's multi-cloud, and I think HCL, which is I think a more readable language or configuration language than the other ones use when they have YAML and JSON or just YAML. So, and so Terraform uses TF files. So if you ever seen .tf files around in your project files that other people have built, you're looking at Terraform HCL. You can version control them and reuse them, and they are good for building a solution if you want to build across platforms also. So I can say, hey, I want to build this in AWS and this in Azure and set up connections between the two, and so it's good for that. So resources. So this is just an example of a Azure resource. So if you see that Azure RM, that is the name of the Azure provider for Terraform. So a lot of people will name their resources off of that just to say what it is, because, well, basically it names that because that's the name of it in the provider. So in the provider, it will always, at least for Azure RM, it will say Azure RM underscore whatever you're trying to build out. And then you give a name, and then you give the address space. So this is for a VNet resource. So the workflow is you create your TF configuration files, you plan it. So everything is write, plan, apply, destroy. So we're going to go through this a lot through this discussion. So if you remember anything about this, you write your stuff, you plan it, which I'll show what it means to plan, you apply it, and then you can destroy it. And some terminology that we'll use going forward. A provider is a plugin that will give you a specific library or a specific connection to whatever you're trying to build out. So that Azure RM is for Azure. I was talking to some guys, I'm doing Fabric, and Fabric, Microsoft has a Fabric provider, so that's just Fabric. And AWS has, basically you can set up and get providers for pretty much anything. So I know we have done it in the past for Identity Server, if anyone uses Identity Server in the Microsoft.NET space. Resources is just the infrastructure components. State, there's a file that is used to track the state, and the plan is kind of the execution plan that shows what is going to be done. Okay, so HCL, so we'll talk a little bit about the language itself. So HCL is a declarative configuration language that's used for IEC. Everything in Terraform is written in HCL. So it's easy to read, easy to write, and there's lots of good plugins for IDEs or editors like VS Code and Visual Studio and JetBrains Writer and most other non-.NET. I mostly do the .NET, so I use the .NET IDEs. But you get plugins for pretty much anything that you are using. So variables. So we'll look at variables a little more in some other slide decks, but I wanted to show variables, how you set them up, what you need to have in them. So for this, I have a location variable, which is going to tell me what Azure location that this project is using. So in this case, it's US East, and the type is a string. So basically, this is the format that you're going to use for most of your variables. So there'll be a description, a type, and a default. And you can set those in other places, but you need to have the default to just fall back on. And you can do more complex types like lists and maps for more advanced configurations. And we'll take a look at examples of a list and a map in a little bit. So these are just different ways that you can do a string, a number, and a Boolean. So they all follow the same kind of format. You have to give it a name, you have to give it a type, and you have to give it a default. Sometimes you don't have to give it a description if you don't want to, but if you do, that will probably help out when other people are reading your HCL after you leave a project or leave a company or something, so it's polite to put some descriptions in. And these are the complex types. So we have a list. So you can just see that down here for default for allowed IPS. So IP string. So we have two IPs that are in the list, 10.0.0.1 and 10.0.0.2, and you just have to bracket those with commas in between. The map is more like a key value pair. So if you're setting up some kind of resource that has many properties in it that you need to set up, sometimes the provider will make you use a map, which it's pretty simple. We've all probably worked with key value pairs, so it's just very declarative. And then how to use variables and resources. So if you remember back in the past, we set up a location. You see we have a var.location. That just means that I am going to take a look at the set of variables, and I'm going to use the location variable inside that set to set the location for this resource. And expressions, so you can set up expressions. They're kind of dynamic. And there's an example down here. Sorry if it's kind of small, but just this is an example of setting up a virtual machine. So you can say, if I'm in prod, if my environment is prod, then I'm going to set up a standard DS2 version 2. Otherwise, I'm going to set up a standard DS1_v2 virtual machine. So this will even allow you to build out, if you set the environment or set up an environment variable to say like prod or QA or staging or dev or whatever you want. So that's kind of nice to have expressions inside HCL. And then we can set up providers. So providers will go usually in a providers.tf file. But in this case, pretty much all of Azure, other than Fabric, which exists on Azure, pretty much everything you're going to do in Azure, you're going to use the Azure RM provider. And that is maintained by Microsoft and it's hosted in the Terraform servers. So it's always updated. It gets updated pretty regularly. So, but that's how you kind of set it up in your configuration file. And then, like I said, the resources, that's just another example for a resource. After every one of these, from now on at the end of every slide deck, I always have a exercise and a bonus exercise that people can go through. And you can get to those out on the workshop website. So, and they'll walk you through everything. So we're going to talk about state. So the nice thing about state is with Terraform is Terraform will not only keep your state, but when you do a plan, when you remember I said you write, you plan, you apply, and you destroy. Those are the kind of the functions that and you can do when you do a apply or a plan. What plan will do is it will take your new configuration files, compare it to what it has saved from previous state, and it will give you a list of everything that it's going to do when you do the apply. So we'll take a look at that. It will save a state file for you. You can either do local state or you can do state file. I always like to do a state file because that way you can push it up into Git and keep it around, and other people will know when they pull down the latest HCL files, they'll know what is going on or what is the kind of the truth for the current infrastructure state. So, like I said, the benefits for remote state is collaboration, and you can kind of most remote state, you can actually save your state in Azure Blob Storage in Azure also. So you can actually kind of, after you push everything up, it will also, if you set it up, push it out to a Azure Blob Storage for later use. And then the when to use it is just kind of when you have a big team, large infrastructure that you have to require consistent state tracking, and you might need to share that state between different CI/CD pipelines and team members. And then this is how you set up. So you're going to create Azure storage account. If you want to set up the remote state to Azure, you're going to set up the that blob storage. You're going to define the Terraform backend, and there's a code down here just to show you what it looks like. You just have to say Terraform backend, give the name of the provider, and then you give the group name, the account name, container name, and then the key. for that storage blob. And then when you run your Terraform init, that will initially run through and it will create that blob storage out in Azure, which will then be used to keep your state, and it will not only keep the current state, it will keep kind of a running list of previous states that your Terraform, that your infrastructure was created using Terraform. So that's kind of a way to set up the remote state. Okay, and then we have some exercises if you want to go through the workshop. So we're going to talk about workflow now. We're going to talk about what I kind of said in the beginning, the write, the plan, the apply, and the destroy. So, but we're really going to just talk about plan, apply, and destroy, because write is, we've already talked about that, and in the big case, the workflow doesn't really rely totally on write. So Terraform plan is the command that will run through everything and do two things. It will make sure there's no mistakes, so it acts like a compiler. It will also tell you what if you're moving from one state to another, what the things that it is going to do to move it to that next state for your infrastructure. So some things it may not do anything to, some things it may update or change, and some things it may destroy. So, and we'll show how it notifies you about that. So it does use pluses for create, tildes for modified, and destroyed, dashes show destroyed. So this is, if I'm creating a new resource, you can see that it adds a plus to the first character of most of the lines of HCL configuration code in here. So this is telling you that this is going to create a new resource group. Now, if I come in here and I have a tilde, that's showing me or you that you're going to modify a resource. So something in here has been changed, and it usually will tell you at the end one unchanged attribute hidden. So it will tell you what is going on in here. It'll tell you kind of what is going to be modified. And then the last one is, if you see dashes, that will be destroyed. So in this case, this resource group will be destroyed when this Terraform project or module gets applied to Azure. So apply is kind of what it sounds like. It after you do a plan, and you do have to do a plan, if you can't just do apply, you have to do a plan. When you do apply, it will take the plan and push that out to Azure or whatever resources that you are working with based on your provider. But this is where it's just going to sit and do work. So it might take a little while for all this to go through and all the changes that are defined in the configuration. So that's really apply. And then destroy, if you do need anything destroyed, based on your plan, you have to explicitly say destroy. So Apply will modify, create and modify, but it won't destroy. You have to I think it's just a safer way of that Terraform. Make sure that you know that you are going to be removing or shutting down some resources. So yeah, I mean, the apply lifecycle just takes the plan, apply the changes, and it also saves the state to wherever you have set it up to save. So if you set it up locally, it will save it locally. If you set it up using an Azure blob storage, it'll put it in there, but that's kind of what is going on with apply. So, and state will only be applied or updated if everything successfully gets applied. So, but usually plan will tell you if there's any mistakes. The only reason why I've ever had issues with apply having kind of barfing and not working is someone goes in and modifies your resources by hand, and they don't match up with the current state. So you always get one maverick on a team that thinks that they can go in and through the Azure portal make changes and stuff. But if that does happen, when you do apply, that will kind of error out. So just know that if you do get apply, go find someone to blame. So now we're going to talk about variables. Again, we talked about them in the beginning, but again, you can have two types of variables. You can have input variables, and you can have output variables in Terraform. And we'll talk about input, because most of the time what you're going to be doing is having a lot of input variables. And that's what will go into either a variables.tf file or a file that ends with, some people even put them in the old way. The original way was TS vars. But most of the time people are using the modular approach to Terraform that we'll look at in a later slide deck, that you just put everything in variables.ts and for configuration that usually works with Terraform, understands what variable.ts means. So, but like I said, again, we have some examples for location and using that location down here that I showed before. And again, remember, I'm doing an all-day workshop. So in the morning, I showed them, and this is probably after lunch. So we do have string, numbers, Boolean, a list, a set. And that is, I didn't show that before, but you can do a set and you can do a map. So a map, what they call a map is more like what I would call an object as a developer. So managing variables and files, like I said, I don't do this. I think Terraform is really moving away from TF vars files, but if you do want to do this, you can say apply, and then you give a name of an external var file. But if you build a module, it will read in for the plan. It will read in the variables.ts and use that for plan and apply. So this is kind of, I think this is I almost view it as the kind of the non-needed way now. So, but I'd still put it in there just to let people know. Variable precedent. So They do load in variables in a specific order. Variables pass directly. You can pass them directly using the -var file. But most of the time for me, or you could explicitly set up a explicit var if you want to in your command line, in your CLI. But for me, I just mostly use I don't even use the tfvars file anymore. I just use variables.tf, and it picks it up. And within that, the precedent is what the order is going down. So this is outputs. So there is a file called outputs.tf that you can set up in a Terraform. I call them projects. They are in complex configurations or build outs. You may have a resource that gets created that you need a key. So maybe an output will be a key or a unique identifier for that resource that will go into another, that will be used as a variable in another build for another resource. So outputs, you do kind of build those like you do your variables. So you'll have an outputs.tf file that lists all of your output variables that then your Terraform will use for if you use them in resource blocks, they'll use it for input variables. So and there's an example of a output. So basically, instead of input, use output, and you basically give it kind of the same configuration. But for value, you can give it the output that it came from. So in this case, if you look up here, I know it's a little small, the value equals Azure RM underscore resource underscore group dot example dot name. So, and that came from where this output was brought out from the creating a resource, probably creating a resource group. So, and this will all be done at the apply, and apply will kick out some outputs that will show you kind of what was going in and what was coming out, and then going into other parts of your build. So modules. So let's talk about how we kind of build out what I call kind of projects, Terraform projects. So modules are just a container that holds multiple resources that are used together. You can kind of build out your files into more smaller pieces. So instead of putting everything in main and having like a 300-400 line main file, you can build it out into maybe resource groups or other things that you want. So that's a nice thing about building in modules, is it helps you kind of organize into smaller pieces and stuff like that. So, and you can build out across different environments also. So why use modules? Reusability. You can, the nice thing is you don't have to keep everything together close to each other. You can say, hey, in your main, you can say, I'm going to be using and go run this module. Like we have different modules in different we use Bitbucket, but Bitbucket Git repositories, and we'll have multiple modules that rely on the same module. So they will just be referenced by URL over to that other Git repository. So you can put all of your modules close together, or you can separate them out and keep them in different places. But so that also lends itself to organization, so you can kind of keep a project clean and structured, and allow you to have different teams working on different infrastructure types. So if you have a team that basically builds out all of the networking layer of Azure, they can have their modules. And if you're building out a part of a solution that's going to sit on the network that the other team build out, then you can say, hey, I'm going to rely on this module, but then I'm going to build out this other piece in my module. So that's kind of how we've done it in the past, or we do it right now. And it's pretty simple how to create a Terraform module. I basically just create a new folder. I put in as a minimum a main.tf, a variables.tf, and a outputs.tf. Then you can add all the other stuff that you want. So remember, variables are for input variables, and then outputs.tf. So as long as you have these three, that is a minimum standard Terraform module, at least from my understanding. Is that, you seem to be a Terraform expert? Okay. It's always good to have someone around to make sure, because I'm a developer who does Terraform. I'm not a infrastructure person that uses Terraform every day. So, I mean, the main is just where you can set up. I usually set up my base resources, anything that kind of needs just to be in main to give that the basics or the foundation for what I'm building out. So in this case, I just have a resource group. Variables, like I said, you can have different variables in here. We have one for resource group name and another one for location. And then outputs is, again, just the output variables. How to use it, I don't think you just kind of use it, and it for now it just kind of works together. But you can build out a module and say what directory you want that module to live in. And you can also say this module is for certain locations and stuff like that. So you can set modules for environments and or locations. So, but for me, I mostly do it around just in a directory, and it just kind of picks everything up and moves it. But there is some more advanced build outs that you can do with modules. Okay, so and then there's some exercises to build all that out, like a web server module, if you want to go through the workshop. So there are some advanced features that I like to show. So provisioners, I am not totally, do you use provisioners? No? So this is provisioners used to execute steps. Should be used sparingly. When to use it, ideal for running post-deployment scripts, so installing software on a virtual machine. This has some examples I pulled up. Executes a command on a remote machine via SSH, and you can do local exec where you exec a command on the machine where Terraform is running. So this is for if you want to go and maybe push software out to a resource, out to a app service, install it or update it or whatever. But that's one thing. And then I do have an example like that to show how you call a remote exec. So you have to give it a type, and you give it the user, and you give it the private key and the host. So, and then you just say for this would just be calling, maybe it's on a Docker resource, just says a Linux machine or a Linux Docker instance, sudo apt-get update, and it is going to install nginx, which is what? It's a web server. So, yeah. So local one would be this. So you're just echoing, just saying the VM has been created, and then pushing that out to a log. So for local, you can use the provisioner to kind of save what work has been done. Then there are some Terraform functions that you can do. So you can join strings, you can get list length, you can say VM size. So this is just kind of for outputs. So you can say, hey, what was the size of the VM? And based on that, it will then, whatever's going to use that output variable for VM size will go out and do that conditional. But if you do want to get like a length or join things together, you can join strings together. Never have used these functions, but I know they're out there. And then workspaces, you can have workspaces. I've never really worked in where I've needed workspaces because I don't really build out very complex environments and complex infrastructure build outs. We have an infrastructure team that builds most of that out. So mostly what I'm doing is building out Terraform for my one or a solution for an application or a new system that we're doing. Use workspaces? No. Where do you work at? You do? Cool. Okay. And this is just takeaways. I mean, we already went through that. So there are different ways that you can learn more about Terraform. There are the docs. There's HashiCorp Learn, which is a free kind of class. There are blogs and stuff. And then there's lots of resources out on like Pluralsight, Udemy, and a Cloud Guru. I don't think that's around anymore, is it? A Cloud Guru got sucked into Pluralsight. And so these are just suggested projects to use for practice. And then another take-home exam, just one. That one is building a complete project to integrate with a CI/CD pipeline. And that is it. Hopefully it wasn't too boring. Like I said, this is usually a full day workshop that you guys would be sitting and working through the exercises. If you do want to see what those look like, if I come in and say like setup, I actually build out and show you exactly what you need to do. like we didn't really talk about this, but for Windows, you can install Terraform really just through their download. There's a download zip. So Mac is a little different. I usually build on my Macs. I use Brew, but you can download the zip file, but you just have to put it in the right place. So I usually stay away from that when I can use Brew. And then Linux, you have to download a zip file or another compressed file, and then put it into a certain place. But you can use VS Code is probably what I use the most for Terraform, because of the Terraform plugin is really nice. I have used Rider for that, and I have used, well, the IntelliJ IDE stuff works really well. And then, but like everything in here will have, I did the hands-on example and then bonus, just so for people that go through these exercises quick, they have a bonus one so they're not sitting around being bored. But this one is just running, writing a basic Terraform configuration and running it. But it should be all still up to date. I don't think much has changed in 6 months or so. But yeah. So this is just out there for free if anyone wants to. And if you find errors, please go out to, it's just sitting in GitHub. Do a PR, please. If you do go through this and find something wrong. But that is it. So, and I went 5 minutes over, so. But thanks.